For today's quiz, we're going to take a heavy object, and this happens to be about 1 kilogram. And it's got a few little loops affixed to this mass. Our question is going to be something like this. We're going to hang it, we're going to pull it, and we want to know where the strings break. Here's what your quiz looks like for today. To help you understand this, we're going to set it up. First thing that we're going to use is a piece of string. And this string is rated at about 1 kilogram. Technically, we should be talking about force, and that's like a tension that can be put on this particular string. It can handle about 10 newtons. And if this is 1 kilogram, this would have a weight of 9.8. So first thing I'm going to do is just cut some of the string. I'll put a loop on each end. I'll just let it hang over itself, make like a knot here with a loop on one end. I'll do the same thing on this end. I'll just hang it over. So I have a loop on each end of my string. And I can cut off a little extra pieces if I don't want them there. I can snip that off. And this one I can snip off like that. So basically I have a loop on each end. I can then take one of these string loops, put it through the metal part of the ball, and I'll take one loop right through the other loop. And this just allows us to do this quickly, if you want to call this quick. And I can put this right on here, right? So this is barely able, and I'm going to put a few books underneath here in case it breaks, barely able to hold this up. It's really stressing that string. If I were to now take another one of these, which I already have made here, and I'll put this one at the bottom, like so. And I'll put one loop through the other loop. And I don't want to pull too hard because remember, this is already stressed to its max. It's only rated for about this much mass or this much weight technically. The question is, if I were to, I'm just going to put a pen through here. I don't like pulling on strings with my finger. If I were to start pulling down on this, which one of the ropes would break? And I'm going to pull till something breaks. Would it be this bottom rope or would it be the top rope? That's what we want to know. So on your paper, if you could list your confidence in whatever your thoughts are. The more that you can write out, the better. Put down your answer right now. So the answers that we expect students to have is that this rope right here would break first. And that makes a lot of sense. If this is already getting ready to break and can barely hold this on, if any more force is put on here, you know, like if a massive dragonfly that was really heavy, you know, were to land on here, you might think, well, that would be the breaking point, and therefore this top rope would break. However, if you were like a magician or something like that, and I could put like a little bit more force down on the bottom here, no, it still always seems like that we're going to end up having the top one break. But if I were to pull it really hard and snap it, you'll notice that the bottom one breaks. And that's the rub. How can the bottom one possibly break? And so that's a little bit of a trick because students think that you're going to pull just a little bit more, and a little bit more. And I can do that. And now, let me make another one of these ropes here. Just make a loop. I should have made another one of these earlier. If I make a loop, another loop here, and I'll see if I can replicate this. I'll put one through here, loop through a loop, just like it did before. Now if I were to pull on this, I can just keep adding more and more force. Oops, this is slipping on me. I can start pulling on it more and more, and in that case, the top one breaks. What's the difference? Since I have one loop on here, I'll just put it back up here. This deals with the idea of inertia. Inertia is the resistance to change in motion. And inertia is synonymous with mass. The more mass you have, the harder it is to change its motion. Just so you know, this is Newton's first law. Objects at rest tend to stay at rest. Objects in motion tend to stay in motion. Well, this object has about 1 kilogram of inertia. If I say I want to pull on you with an incredibly hard force, this is going to end up saying right back to me, no, I am an object at rest. I'm going to resist you changing that state that I have. So if I end up having a rope on the bottom and I say, look, I'm going to pull on you so hard you're not going to believe it. You're going to accelerate so quickly. Well, the problem is to accelerate a mass, to a very large acceleration, you're going to need a very large force. And this little rope can't supply that, and so it snaps on bottom. On the other hand, if I were to pull very, 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 very slowly and just add a little bit more force, this one up here will always snap. So this is a little inertia trick that we can use. And that's your quiz for today.